Hello Internet, welcome back to Let's Make a Squash Shader. I need to get better at figuring out what I'm going to call these things. So this is sort of what we have now. You can see it's kind of working. We're kind of getting a splat every so often. But it wasn't really what I had in mind. So if I just step through, you can kind of see what happens. Things are actually kind of falling through. And that's just because our sphere shader is actually, or our sphere collider is actually pretty small in there. It's only for the center. And so that was to allow them to kind of fall through the center. So we do get our deformation. What we were playing with last time was if we rotate this, everything breaks. And so that's not good. And we also are having some other issues. So I think what's happening is we're not translating everything from world into, or object into world space, and then everything back into object space. And so if we fix that, theoretically everything will work better, and this should go away. So if I keep going, you'll see everything looks perfectly fine. It looks like it's doing sort of what we want, and it's squishing. The issues are more things aren't looking right. So you notice like the squash goes below our shader. And if I keep dragging this down, it'll actually just keep getting bigger and bigger and bigger. And we don't really want that. First off, all of these vertices are supposed to be clamped to this collision point. So they're all supposed to come up. But that isn't happening. So I think what we can do is we actually want to do the max here of our world position Y and our squash limit. And so this will only work for things that are like what we're doing, like below. But the idea here is if we're above, we'll take that. And if we get below, we'll just clamp it there. So then let's translate this back into here. So we've got our world position, and theoretically, I could be wrong here, but theoretically this will give us the correct transformation because it's going to give us our up vector in that direction. Could be very, very wrong. Yeah, so the difference is being set to 0 for some reason. And I think that is because something is 0. World pose.y is 0? Maybe that's our issue. So the issue with this is I haven't debugged this at all since we left it off. I got home from work, fired this up, and we're here. So kind of playing around with this in my head. So there may be more cuts than I usually have in here just because I don't know the solve yet, and I don't really know the issue yet. So I'll try to keep the issues in, but not everything else. Anyway, we're gonna look at this and try to figure out what the heck is going on. So to start off with, we translate everything into world position. Then we get a squish amount, which is the minimum value between our world position or our squish limit. And it's going to be a positive value, and that's going to represent... Why are we doing a min function here? I mean, it's working. Okay. This will only work, I'm pretty sure this is going to work for 0. If we change that up or down, I think it'll break. But we're working with 0, so it should be fine. Next, normal stuff. We have our multiply, so we're multiplying our normal vector into world space, getting world space normals. Then we are setting the normal y equals 0. And then if we still have a vector, then we're going to squish it. And we're going to squish it like that. So it's just going to go zoop and squish out. Now I'm wondering, can we just do that y plus or minus equals squish? Now this is only going to work at 0, but I'm curious what happens. Oh, geez. So it grows. So I think we're going the wrong way. So if I add this, what happens? We're kind of getting what we want. This is more just trial and error. Oh, too much. But we are kind of getting that squish shape that we want. It's just too much. Way too much. So how do we fix this? So it's going down. And it looks like it's equal to, so this is about at 0. So it looks like it's 2 times as strong. So it's reflecting it perfectly. We don't want that. We only want half. So I'm just totally guessing in the dark, trying to get an effect that looks like what I want. There we go, half. So now it squishes, and it does hit the ground perfectly. So now we can squish our ball against the ground, like so. And it works. Cool. So we fixed that issue. I don't really like how we fixed it, but we can make that better. And actually, it's probably pretty all right. If I drag that up there, do some more of that, we can increase the squish amount, and you'll actually see it should still a little bit fast, but it's kind of looking better now. A little bit. Does it look better? I feel like things are moving too fast for this to work. So we can fix that actually. I take all these balls and move them down. Like that. Now they should just barely bounce above. There we go. And so it's kind of getting a squish going. Next, how do we want to fix things? So this is going to get it so it's equal there. One thing I'm wondering is I think we want an additional modifier on this squish. And the reason I'm thinking that is because right now it is very defined. Like you look at this, and I'm in the game view, so I can't do that. But I'm in the game view, or I'm in the scene view now, so we can look at this. Oh, it actually does grow a little bit. Oops. So there's a bit of an error there. Okay, so the solution doesn't work perfectly yet, but it works relatively. And I guess that's going to be good for now. So we have it kind of squishing, and those shadows are really weird. But what we can do with this is I think we want more than just these vertices that are below it to kind of be part of it. I think we want some sort of, like, I don't know, something that'll allow more of the object to get in there. So how do we do that? We're going to need like a ramp, right? So what I'm thinking is squish is going to be 1 if it's completely squished, and 0 if it isn't at all. And so we're going to add another property here for our squish. What do we want to call it? So like, I'm trying to think of like rigidness. Squishiness. That is not how you spell that, is it? Oh well, we'll do it. And we'll set that equal to, like, something's going on outside. Anyway, take our squishiness and plug that in down here. And now the idea is this is going to be our ramp. So how do we want to do this? I'm thinking it can be our point above here that is affected. So I'm going to actually simplify this a bunch and say squish equals 1. Oh, jeez, my hair is going crazy. All right, we'll fix that later. All right, squish equal to 0. And then if our world pose.y is less than our squish limit, then squish equals 1. And then else if our world pose, if our world position dot y is less than our squish limit plus our squishiness, then squish is going to equal some function of those three. So what we know is that world pose is going to be in a range between squish limit and squish limit plus squishiness. So we want 1 minus the world pose.y over our squish limit plus our squishiness. So what this is this is going to be our upper bound, and then our world position is going to be our other bound, and then we want to take 1 minus that. So when world position gets very close to 0, then it works. We'll actually have to subtract the squish limit from this, I believe. So as the world position gets closer and closer to the squish limit, it's going to become 0. And as it becomes 0, this function is going to get smaller and smaller. And so because of that, when we're taking 1 minus that, we're going to get closer and closer to 1. And as this grows again, since it's between this range, it's going to be between those. So that's the idea. And it's broken. Nice. What is broken? It looks like we're missing a few things. Semicolons. Semicolons are good. Other things we should do is fix our brackets, because order of operations is going to make that division happen first, and that will break everything. So let's do that and recompile, and there we go. So now if I select this, we should be able to up this. Oh, yeah, up this a bit, and it'll kind of smooth it out. Oh, that's kind of funky. So the one thing I did do before I started recording is I made the ground glass, just so it's a little bit easier to see. I'm not sure that was effective, but Cool thing with this is it seems to have actually changed the effect for the better, actually, because it kind of is maintaining its shape a little bit, and that's just because it isn't below. Oh, that may be a problem. No, it isn't. No, it should be hitting the ground there. And so it kind of will ramp out there. If we increase this, it will bounce out a little bit and bounce back in. So everything's as it should be-ish. The one thing I do want to do is we're going to add a squishiness ramp scale. And so this is just going to be a exponent on this function. And since it's between 0 and 1, it'll give us a nice curve like this. So obviously if you square 1, you still get 1. But if you square half, you're going to get 0.25, for example. And so you, instead of getting a linear line like we're getting right now, we'll get some sort of ramp, so it'll kind of ramp out. And so things will, you can make things go either way. If you make this scalar like fraction, it will do the opposite. It will kind of bend out. I don't know what shape does that, but if you want it to, this will let us do that. So we're going to add that with this. I'll set it to like 8. Why not? It's not like I know what I'm doing anyway, so plugging in random values not going to make a big difference. So we're going to take our squishiness scalar and we're going to multiply our squish by that. So we have that there. So we're just going to take it and run it through a pow function, which is just taking the power of something to a specific exponent. So we're just taking squish to whatever power this is. And we're just plugging in a float. So hopefully we can do some fun stuff with this. Oh, yeah. So you can see it ramps out a lot. You can actually kind of see the curve here, kind of going like that. And so as we change this, you'll see it change. So as I reduce it, it gets more and more linear. And that's pretty close to linear. And then the problems with our shader become apparent. And oh, that's what's going on. I have created a monster. So let's not do that. But it does, for the most part, work. Though it does kind of mess with the topology a little bit when you make that a little bit too small. Makes it happen a little bit fast, but the cool thing is it for the most part works. So you can splat things better. Anywho, I think actually I'll probably leave that here. I'm going to record another video of this and we're going to actually fix this, because what we have right now for actually fixing the Y position obviously doesn't work because we're below. But the cool thing is this part works. So we can actually like splat things now, and it kind of looks like it splats. With these, the gravity is a little, actually, that looks pretty good actually. I'm pretty happy with that. So the shading's a little bit wrong, and that's just some lighting issues that are going on. I think we can actually fix that quick. If I go in here and pull out this full forward shadows, I think that might fix those issues, but I'd have to check. Nope, doesn't fix them. Okay. So what that full forward shadows is doing is it's adding Unity's like standard shadow stuff, plus it's making it so we can do some, what's the word for it? some actual shadows, I guess, for our forward shadowing stuff. So forward shading is, forward rendering is just a form of rendering. It's the standard. It's if you have transparent stuff, it's the only way you can render. If you have stuff like this, the other option is deferred rendering, which we don't really need to worry about. Might talk about that later, because that's actually really interesting the way that works, but I'm not going to talk about it now. I've said that a lot in this series. I feel like this is part of why people don't like shaders, because there's a lot that is out there. Anyway, I'm going to leave this here, and we're going to pick this up and actually finish our Y clamping. So this doesn't actually, doesn't go off into the sky, because it kind of, like, I kind of like this effect because it kind of ripples out and kind of juts back up into the air. But at the same time, it's wrong. So I don't like that part of the whole it being wrong. Also, I don't think it's on the ground. Yeah, I think we have a levitating circle. So I think our math is just totally messed up. but we'll fix that in the next video. So until then, I hope you guys liked it. And if you did, leave a comment below and let me know what you think. I like to hear what you guys say. So that's it for now. So see you guys next time. See you, Internet.